Okay, now we're going to look at 1955. So the first thing we want to do is we'll draw a picture. So I have a 4 kilogram block here, and it's hanging by a string. Then I have another string, like this, that's attached to it. So if I have two strings, that means that I have two tensions. So this is T1 and this is T2. So it says determine the tension in the top string, T1, and in the bottom string. So you have to look at the individual free body diagrams. So here is the 4 kilogram mass on the top, and here is T1. Now the weight is pulling down, but the weight that's pulling down on here is going to be the weight of the two blocks combined. So when I sum forces, and I say summation of F of y is equal to ma. Now this is in static equilibrium, so they're not moving. So this is equal to 0. So T1 minus the weight, which is the 4 plus the 6, because I have to take into account this, is equal to 0. So T1 is equal to Fg 4 plus 6. So T1 is equal to 4 kilograms plus 6 kilograms times 9.8. So 10 times 9.8 comes out to be 98. Now I want to find, so remember, that's the free body diagram. I have this string, and then I have the weight, but I also have to consider the weight of that. For part B, so that was part A, now I'm going to look at the free body diagram of the 6 kilogram block. So the 6 kilogram block has this tension here, and then it has the mass of just a 2 kilogram block times gravity, so the weight. So now again, I'm going to apply Newton's second law. Summation of F of y is ma. It's in static equilibrium, so that's equal to 0. So now I'm going to look at my free body diagram. So I have T2 minus Fg6 is equal to 0. So T2 is equal to Fg6, which is equal to mg. So it's 6 kilograms times 9.8 meters per second squared. So T2 is equal to 58.8 newtons.